Welcome to part 3 of skimage tutorial. In this tutorial, we're going to cover one very important functionality, which is histograms. How do we create histograms for a given image? And we will see as we progress forward, work more with image recognition, histogram or ability to plot histograms is a very vital capability, and that can be used to really differentiate, categorize images. So let's learn more about histograms. Um, Right. So what we can do in this part is first look at how to plot a histogram. That gives us a good feel of what histogram is really and what are we talking about as a histogram of an image. And then we'll go into some conceptual understanding of what is a histogram and then some the technical aspects from a conceptual perspective. So let's go ahead and create the histogram first and plot it. So how do we do it? So there are multiple ways of doing histograms. So one of the ways is use numpy function to extract histogram variables. So numpy provides something called np.histogram. Np is a variable we imported numpy as. If you go up and look at our imports, it'll say we imported numpy as np, and that's how numpy is always imported in a standard way. So when we do np.histogram, we are passing a couple of arguments to this one. First one is image itself, for which we want to plot the histogram. And the second is how many bins, how many segments we want to create in that histogram. So here in this case, we are passing the number of bins is equal to the total number of the length of total values that pixels can take. Length of total values that pixels can possibly take. We know that pixel values can vary from 0 to 255, and that is the reason we are taking the range of this entire spectrum, or all possible values, which means they could be all in all about, not about, exactly 256 values that we could that the pixels could assume, right? What we have to measure is, as part of the histogram, is what is the frequency of a given pixel value. So let's say a pixel has a value of 10. Within the entire image, how many pixels are there that have pixel value 10, right? So you count that. Then you come across another different pixel value in that image. Let us say pixel value is 50, right? So how many pixels are there that have a pixel value of 50? So you count that. Likewise, you find out the frequency of each of the pixel values. So people who have a statistical background will be able to immediately correlate with what I'm trying to say. But if you don't have statistical background, don't worry, just have a little bit of patience and we'll come down, draw a diagram and understand this in a greater detail. But for the time being, for the sake of curiosity, let's go ahead and try to plot a histogram. So when we do numpy.histogram, we collect the output in two variables. One is the number of the values and the bins. The values are the frequencies. What is the frequency of every pixel value, right? So let's go ahead and run this. Okay, so now our variables, values, and bins are loaded. Now let's try to see what is the shape of the values variable. Shape of values variable is 255. So there are 255 values, frequencies of each of the pixel values. Then we see what is the shape of bins variable. Let's try to print it. Okay, so number of bins here is 256. So as you can see, there is a difference of 1 between the values that we got and the number of bins which are there. That is the reason when we plot histogram, we have to make sure the length of values and the length of bins, it has to be same. If there's a discrepancy, we'll not be able to plot it. So that is the reason when we go ahead and try to plot the histogram, which is basically a plot of the bins and the values. We have to make sure there's no discrepancy between the number of bins and the number of values. Right. So we exclude the last bin, and we take the total number of bins as 255. Right. So let's go ahead and do this. Okay. So let's run these lines of code together so that we are able to specify the X limit, Y ticks, and so on. And we can also set the title of this um, plot on axis 1 as histogram. So let's go ahead and do that. And let's visualize what it is looking like. So we've got a very nice plot, a graphical representation here. And that's the histogram of the image that we are talking about. So just to understand a bit better, what are we really looking at in this graph? So what you see on the x-axis are the pixel values. What you see on the y-axis is the frequency of those pixel values. So we see that somewhere here, somewhere closer to 100, or this could be somewhere in 80s, between 80 and 90, the frequency of those pixel values is maximum in this image. And as we go towards 255, such such pixel values are less occurring pixel values. Similarly, pixel values with zero value are very less occurring. There's very less occurring pixel values of that kind. Then again, there's quite a bit of pixel values at somewhere between 150 and that is around 175. So that's the histogram. And as I mentioned, let's try to create a diagram and try to understand what histogram really means. So let me take help of diagram here. So as you saw, the histogram really looked like this, something, and then it was a bit jagged and so on. And pixel values varying from 0 to 255. So you remember we talked about something called bins. And on the y-axis, it is the frequency of the pixel values. For our understanding, let's call this as frequency. These are the pixel values. So pixel value 0, 1, 2, 3, so on, right up to 255. This is p value, that is pixel value. This is frequency. Let's say for 0, there's very less frequency, 10. Somewhere we saw it was about 80, at which the frequency was very high. So at 80, it is reaching 400. Such pixels at 255, again, it drops to about 10, so on. So this is what we mean by bins. What we can also do is, it's not really necessary that you need to have 255 bins in itself. You can have less number of bins. So let us say you want to have 50 bins. So what will happen is we'll club these 255 potential independent values of the pixels into 50 equal buckets. So really speaking, you won't see 255. So you'll see maybe here 5, here could be 10, so on, 25, and here it would be something called 50 here, right? So within these buckets, you will redistribute these pixel values, right? So let's say the first bucket would have pixel value, so 255 divided by 50, 5 fives. So every bin will have pixel values ranging from having a width of 5, right? So the first bin will have pixel values ranging from 0 to 5. Second bin will have pixel values ranging from maybe 6 to 10. Next one will be